Let's look at a couple of interesting questions on harmonics. As we know, standing waves are formed when two waves of equal amplitude, frequency, and speed are sent in opposite directions. And there are always points called nodes. These are called nodes where there is no change. And these are antinodes where there is a maximum amplitude that's formed. So based on the natural frequency and so on, we know that there are different harmonics possible for closed pipes and open pipes. These are closed pipes and these are open pipes. Now, one thing to note is that the representation here of the waves is transverse, but we are going to look at how sound waves travel in these pipes. Sound waves we know are longitudinal. They go to and fro. The direction is parallel to the direction of propagation. So now, two basic questions. One is, why are nodes and antinodes formed only at specific places? For example, if we take a closed pipe, why, uh, for example, why antinodes are at open end, right? And it also leads us to the question why nodes are at the closed end. Now, if we look at sound waves, these are nothing but molecules of air here, which compress and undergo rarefaction, which means they move away from each other and move towards each other. That is how they progress. And when they are closest to each other, that point is a compression. When they are away from each other, that's a rarefaction. Now, the reason these antinodes are formed at the open end is because, as you can see, this end is open to the outer area or not inside the enclosed space. So there are a lot of free space for the air molecules to move about as opposed to the closed end. You see the closed end here, the molecules cannot move as freely as at this end. Hence, if we plot a pressure wave or the pressure plot, then the pressure would be minimum here. It would move something, the pressure plot would be the opposite of what is. It would be minimizing here. And it would be maximum here. The pressure would be the maximum here. It would be the opposite of this plot which is already there. Now this chart that is already there is called a displacement plot. So which means the displacement is maximum here and the pressure is minimum here. That's why the antinodes are getting formed here. And we know only for specific formations or specific frequencies we get these standing waves which create the harmonics. So the other question is, question 2 is, why do they get reflected? Now at the open end. Now logically, intuitively, we can say that if we push something and there is a closed end, it gets reflected in this closed pipe, for example. But why do they all also get reflected at open ends? What causes the air to get the longitudinal wave to get reflected at the open end? The reason for that is, let's imagine we push air through this end and then there are compressions and rarefactions. Some musical note is being pushed from this end. There are compressions, the rarefactions, compressions, rarefactions. That's how the wave moves. And when it reaches here, what happens is, as it moves out quickly, then there is a sort of, vacuum, not a real vacuum, but then a temporary dip in pressure that's created. So the air here, the air molecules, rush in to fill that. They rush in to fill that space. And hence that forms like a block, and that's how they get reflected back. Now, these waves get reflected back, and then we know that when we superimpose two waves, which are exactly, opposite, but with the same amplitude and frequency, we get standing waves.